Thank you very much for sparing time from your busy schedule for this activity.
No problem.
So I would like to introduce our today's speaker, Dr. Noman Hai. He holds the PhD degree from University of Waterloo and the MS from the Linköping University, Sweden, and PhD degree from the NED University, Karachi. So he has a vast experience in designing in a multiple company like the Philips, Macom, Marvelous, and now serve as senior design engineer at the Synopsys, that company that is one of the leader in the CAD tools. So in the today's talk, he would teach that how the high-speed chip interconnect designs, and as you are familiar with, sometime we discuss in the classes also how serious is the interconnect. So he would try deep dive in those topics and how we can speed up those stuff. So thank you very much, Dr. Numan. So now over to you.
I don't want to go too much technical. What I'm trying to do here is, okay, when I started my undergrad or grad school, I was like 22, 23 years old at that time, grad school at that time, or even undergrad, 18, 19, like I'm talking about like around 27, 28 years ago. तो उस वक्त जो है ना बहुत सारे मैंने courses, I did my from NAD, मैंने बहुत सारे courses करे, which some courses I do not like it. Some courses I just say, okay, may not be useful for me, and other thing, and so on and so forth. But I really regret some courses I should have paid much more attention than I should have done at that time. So I just want to give a little bit an overview. कि कौन-कौन से courses are important, specifically the field I am in. Okay, so I'm gonna start with I'm calling this talk as a theory to silicon, and he said how our classes prepare for our high-speed chip interconnect design. So you see, I'm using quite much words. We call it jargon. तो आपको जो है ना क्योंकि you may not be familiar with all these terminologies, मगर हमें ये terminology use करनी पड़ती है. Same thing अगर आप फर्स्ट करें, आप क्रिकेट के प्लेयर हैं, आप ये कहते हैं कि बंदा सिली मिडॉन पे खड़ा हुआ है. You do not tell कि वो किधर कौन सी एक्सपेक्ट पोजीशन है. The moment you say the way it's on silly midon, you already know where he's sitting. Or this is a keeper, you know where the keeper should be standing. He's a fast bowler, or he's around the wicket, or the round. These are the jargons we use in a word, so that we do not need to explain everything. तो इस तरह से हर सर्किट्स में और हर टॉक के अंदर ऐसे वर्ड्स आएंगे जो आपको अंदाजा नहीं होगा कि इसका मतलब क्या है. That is my job to make sure that you understand that point here as well. So high speed, you already understand high speed kya cheez hai. Interconnects means which anything that connects two things, we call it interconnects. So we're talking about on that aspect here. So let's start with the motivation. So I'm gonna start with the very high level. So hum, I can imagine, I don't see many people, but I can imagine 80% of you on the cell phones texting some messages. Is I'm correct or no? कि हम जब सेल फोन के ऊपर होते हैं, then we are making quite much, we make jokes. I don't know that this packaging thing, I don't understand that part. The night packages क्या है, वो कौन से packages, I don't understand it, but we keep hearing on the news what is going on there. So when you have this internet, you already have smartphones and internet, social media with us. तो हम इसके साथ साथ हम इसके साथ content भी create कर रहे हैं. What does it mean by a content creation? Same thing. ये मैंने जो slide बनाई, that's a content. That's what I created one thing. एक मैंने ये copy करी एक website से, and then I write something. I created a PowerPoint. I created one content or one data I generated. So इस तरह से हजारों किस्म के डेटा जनरेट हो रहे हैं, जो कि बहुत सारी चीजें आपको अंदाजा है. व्हाट्सएप मैसेजेस वी डू इट, लिंक्डइन के ऊपर आप सब काफी सारे लोग मौजूद है. इफ यू आर नॉट ऑन लिंक्डइन, you're technically not existent in the technical community. So everybody should get a LinkedIn account as well. And then you learn about what other people are doing too. So LinkedIn is there. Cyber criminals, Instagram, DoorDash. It's not that popular in Pakistan, but I think here is very popular. Venmo is a way you do the payments. Um, People doing the trading and on the internet, watching Taylor Swift, Facebook, ChatGPT, Instagram. These are all different kind of contents we are creating every minute of the day. Huge amount of data. उसमें से बहुत सारे हम खुद भी काम कर रहे हैं. जैसे हमारे कैनवा के ऊपर कोई कोई डेटा जनरेट बना रहा है, कोई कोई लोगो क्रिएट कर रहा है, कोई यूट्यूब वीडियो बना रहा है. Anything you do on internet or on your cell phone, you're you're generating a data. But most of the time, or you take a photo as well. That's a data as well. You take a photo of a bird. That's a very good photo, but that photo needs to be sent to somebody else. Otherwise, हम हर चीज हम अपने पास नहीं रखते. We are communicating with each other. That's the reason that a huge amount of data is being generated every day. You can understand कि कहाँ से ज्यादा generate हो रहा है. And the most important thing is that generating data is not that important. Communicating that data or moving that data or transporting that data is as important as creating that data as well. Okay, so this is how the data is moved. अब अगर आप अपने जहन में इस्तेमाल करें, if you have cell phones, you always understand. आप अपने cell phones के अंदर you have a WhatsApp message, you send it to your mom, some message, but you understand. You write down a text. That text is a part of a WhatsApp app. That when you press the send button, that data should be converted into some kind of signals, which signals goes through your cell phone to your cellular network, to your cell towers. और उस cell towers के जरिए most of the time they use optical cables. From that cell tower they go to a data centers. डेटा सेंटर कुड बी एनीथिंग. यूनिवर्सिटी आल्सो हैज देयर ओन डेटा सेंटर. डेटा सेंटर का मतलब है ऐसी जगह जहां आपका डेटा आ रहा है और यू आर प्रोसेसिंग इट. It could be your university campus, it could be an Amazon server, it could be Google Cloud server, or so on and so forth. So you do that thing. ये हम जो डेटा भेजते हैं cell towers is used mostly through optical cables, or when they are in within data centers, they are usually working on electrical and copper cables there. और पीसीबीज जो हमारे आप समझ लें कि आप अपने हमारे एक पुराने जमाने का जो डेस्कटॉप्स होते थे, आई थिंक स्टिल मे बी अवेलेबल. आई डोंट सी इट एनी मोर. मगर अगर डेस्कटॉप अवेलेबल है, यू कैन ओपन इट अप इंटरनली. देयर इज अ कनेक्शन गोइंग ऑन विद डिफरेंट ब्लॉक्स. दे आर मोस्टली डन ऑन पीसीबीज और यूजिंग इलेक्ट्रिकल केबल्स, और इवन आप यूज एचडीएमआई केबल यू यूज for your laptops or for your screens and so on and so forth. और ये same thing happens on the other side as well. जब वो data generate हो गया, वो जो message आपने message करा है, the moment it goes to the data center, they process it, they encrypt it, or then they send it back to the recipient. Okay, so the same goes on the other side too. So there are many ways to communicate. उसमें wireless का भी आ जाता है, उसमें optical भी आ जाता है, उसमें अभी समझ ले कॉपर केबल्स भी हैं. अब आप यू कैन मेक एन एनालॉजी कि इफ यू वांट, पुराने जमाने के अंदर यू राइट डाउन लाइक एक्चुअल लेटर्स. So letter is also part of a communication. Somebody has to write a letter, send it to a post office. वहां से postman पकड़ेगा, लेके जाएगा. This all part of a communication, and that's how it's been always been there. But in this specific talk, I'm mostly focused on electric and copper cables, जो कि हमारी जिंदगी में मौजूद है. जैसे हम HDMI केबल है, SATA केबल है, USB cables हैं जो हम यूज करते हैं. अगर आपके पास iPhones हैं, then you have a different display port cables, and or type C cables are there. USB के different cables हैं. They all cables are allowed working on electrical. We call it electrical and copper cables here. So I'm focusing on that part. Okay. I'm going to introduce another concept here. They call the concept of called SerDes. SerDes is a short form for serializer and deserializer. So you can imagine कि हमारे सेल फोन के अंदर जो काम हो रहा है, that's mostly doing on digital. They are doing many parallel processing was happening. There are many parallel bits are moving around. मगर जब हम मूव करेंगे डेटा, Tanveer Ahmed Khan, you can mute yourself, please. Thank you so much. Okay, so तो जब when we move the data from one side to another, we use the wires. तो हम ये समझ लें कि हमारे कंप्यूटर में या लैपटॉप के अंदर जो डेटा पैरेलल डेटा है, we move it to somewhere else, usually in a serial fashion. तो आप ये इसको आप ध्यान में भी देखते हैं कि HDMI केबल है. जिस तरह से HDMI केबल है, अगर आप अपने लैपटॉप से कोई मूवी देख रहे हैं which you projecting on your TV, that जो नेटफ्लिक्स पे जो मूवी चल रही है, that's not one single bits. There are millions of bits moving around. Magar, they go to the TV on a serial channel on HDMI. That's a very efficient way to get things moving from one part of the component to another part. Okay, so this is one thing, and then SerDes help send the data efficiently between chips. So हम chips से भी बात कर सकते हैं, but it can be talk about systems as well, and with the and long distances without losing speed or accuracy. That's usually the definition of a SerDes. Anybody have any question here? Okay, somebody asked a question.
Uh,
Mr.
so,
Nitin,
so sir, what about the images? Are they also serial? मतलब वो भी serially उनका जो data transfer होता है या कोई इस तरह का UART type कोई interface इस तरह?
No, it doesn't matter. कि data किस कौन सी for you it's an image. For a computer, doesn't matter. Computer doesn't understand is it an image or is it audio or a video. It's just a data, and there's a different ways to send the data. So for you, is an image, but for the computer, it's just number. It doesn't understand. It has no feelings for that for that image. So you can use any technology. So one way is to send serially, but there are other ways. You can send it parallel, and there are different ways to send it. UART is one option. USB is another option. HDMI is another option. Ethernet is another option. You have a copper cable is another option. Sorry, Ethernet cable is another option. So there are different PCI. Um, if you open an old desktop, there are PCI cards as well. The PCI cards are also some way of communication as well. आपके पास पुराने I don't know right now. No, you have to have like a cards for the RAMs. तो आप RAM को जब अपने डेस्कटॉप के अंदर लगाते थे, that is also a part of a connection. There's a DDR connection there. So there are different communication protocols. So there's no one single protocol. Okay. Yeah. Go ahead, Shahryar.
Sir, in which scenario there is point-to-point communication?
In what scenario this point-to-point communication? What does it mean? Point to point. Okay, so point to point means that there is a one source and there's another host. Okay, so you can send from one side to another. That's called point to point communication. But if you're asking me something specific, I don't understand. Maybe there are different ways to say point to point communication. आप अपने किसी अगर आप अपने लैब के अंदर कोई काम कर रहे हैं, if you have one computer sending a data to another equipment, you can say it's a point to point because there's nobody else in the middle. So that's also a point to point communication. But there are many. This this word can have a different meanings. There's no specific word point to point.
Actually, जिस तरह अभी आपने बताया कि ये जो serial communication हो रही है, like
Hmm.
from HDMI we are watching in the on the
Yes.
big projector, तो ये point to point में ही आएगा कि जी एक point से आपने दूसरे में data transfer किया है, और ये
Yeah,
जो
you can say
communication है interconnects
you
की
can.
ये through buses के through हो रही होती है.
Yeah, exactly. They are bus, but we call it like a serial bus. Okay. So bus means when we say the word bus, that means it has many multiple data going in parallel. मगर हम उसको कहते हैं serial bus because still you need two wires to send the data, positive and negative. So still you can call it a bus just for the sake of calling it a bus, but we call it a serial communication in that sense. These are all different jargons, so there's no one specific answer to that thing. Okay, so किसी ने सवाल पूछा कि parallel is faster than the serial, but that's not the case. Yes, parallel is usually slower. Parallel per bit is slower compared to a serial one. That's why we do it. मेरी मैंने लेक्चर दिया था कुछ महीने पहले at NUST at the same time. That's also on YouTube. You can ask you can ask Hassan as well. He can send you the link. And there I talked too much into detail about what is the difference between parallel and serial. मैंने वहाँ analogy भी दी थी. I can also give an analogy as well. कि if you're going from अगर आप जा रहे हैं फर्ज करें आप इस्लामाबाद से आप जा रहे हैं एबटाबाद or take it farther away from Islamabad to Karachi. There are two ways to do it, maybe easier way. One way is that you take a train. The other one is you take a bus. The other one is you take an aeroplane. Aeroplane you can think as a serial communication, but it's more expensive. क्योंकि अब सीधे आप अपने एरोप्लेन से जाएंगे, not much hassle. Everybody goes in at the same time. It's very fast, very secure, and so on and so forth. Whereas if you go by bus, there's a chance that many people are going at the same time. It's very slow, but you can send like thousands of people at one time. Whereas in aeroplane you cannot do that thing. So there's a difference in that thing. So parallel is usually slower per bit, per line, we should say. Serial is much faster. There's another concept we call it a throughput. The throughput is different. It means you can have thousands of lines running. For example, you have 1,000 lines running at 1 gigabits per second. So now you have thousand time 1 gigabit is 1 terabits per second. You are sending the data, whereas you do not have a serial link which can run at 1 terabits per second. Usually, a serial link is like 100 gigabits per second. So throughput ज़्यादा होगी parallel के अंदर. It could be, but serial is usually faster per interconnect or per line. I'm trying not to use too much jargon, so that's why I'm a little bit taking time to make it take it slow to make you explain. But that's usually the case there. Okay, anybody has some question there? I'm gonna. Okay, yeah. Throughput is better. Okay, good. So let's continue. Yeah, are there any other question here? Maybe something will get more clear on that. So this is a high level overview of how the SerDes look like. Okay, so now I'm introducing few concepts here. There's a transmitter here, and it goes through a channel and it goes to a receiver. Okay, so think about your own case. मैंने आपको अभी जो example बताया, you're sending a text message from your cell phone to send it to another person. So, who is a transmitter? Your cell phone is a transmitter, and the recipient's phone is the receiver. Okay, think about that thing. What is the channel in this case? What do you think? What will be the channel?
The
Anybody?
towers we're using.
One of the tower, but there's not. Okay, yeah. So you can understand that there's not one channel there, because the moment you send a data, press the send button on your on WhatsApp, is going to convert that into a transmitted signal, an RF signal, which goes to from our electromagnetic media, goes to the cell tower. So that's one channel. From cell tower, it goes to your data center through an optical cable, and from optical cable, it goes to a data center. When it goes to the data center, the WhatsApp message, they're all encrypted. So they're gonna send it to something else. They're gonna do the encryption, and they find out, okay, acha, that person is maybe on the other side of the world. So we need to send this data to maybe transatlantic. Maybe that person is in the US. Then you send through another optical cable which goes under water through optical cables to North America. From North America, they goes to the data center, they do all the processing, and then on electrical channels, they may send it to data center, and this data center will send it through the wireless to the recipient. So it goes through many channels here. Here I'm just showing one channel, but there are many channels in the real life, in the real world. So I'm just showing this thing works like that, that rather than sending all data at the same time, you send one bit at a time, such that you save on the wiring cost. Think about it, that you're going to send a data from Pakistan to all the way to North America, and it usually goes through an optical fiber cable going underwater, under ocean cables there. You cannot have too many cables. You can have only one cable. You want to have one cable to send all the data. So that's a very good example, that you want to send one bit at a time, such that it can be very high, fast speed, but you are not increasing too much cost to the system as well. Okay, that's the overall view of SerDes. Okay, so now I'm gonna go a little bit into block diagram. I don't want you to really pay too much attention. What does a block diagram looks like? But what I'm trying to show is that you understand the concept कि एक जगह से हमने data transfer करना है दूसरी जगह पर. There are many ways to do it, but a logical way is you can think that you have two chips on your laptop or your motherboard. You have two chips. One chip's on the right side, one chip on the left side, and you want to connect them through a PCB traces. That's a very easy example. So there is a transmitter signal. Maybe there's a CPU who's gonna send the data to another CPU which is on the other side, or the GPU, or on the other side of the motherboard. Okay, and here is our channel. When we call it a channel, there's a different name for this one. We call it a channel. We can call it a medium. We can call it a cable. In this case, it's a PCB trace. It could be a PCB trace. It could be a wire. It could be an optical interconnects. It could be a wireless interconnect. Okay, but in this specific case, we're talking about PCB के अंदर हमने जो है जो वायर कनेक्ट कर रहा है एक चिप्स को दूसरी चिप से just for easy understanding. On the left side there's a transmitter, there's something which transmit the signal, or on the other side there's a receiver. You can think about it that you have a, yeah, or you can think another way. You have a laptop, you're watching a movie which you want to send it to your TV. Maybe right now it's doing the same thing. You may have a streaming going on. On laptop, you have a Google Meet going through, and then somewhere there's a connection on that laptop which is going to your projector. You can think from that perspective as well. So, what projector is a receiver, and that is also doing something else, and is just projecting the data on your big screen. I'm just assuming that may be the case there. तो एक तरफ जो है हमारे पास ट्रांसमीटर है और एक तरफ हमारे पास रिसीवर. That's the job of a block there. So अब the point I'm trying to make is that this is very easy block. On the left side transmitter के अंदर ये है कि हम एक transmit करेंगे. Transmit could be anything, could be a wireless transmitter. In this case we're talking about more 1010, more digital kind of a transmitter. Usually we do termination. We already know we terminate the signals. अगर आप we're still using the cables from the on our TV, you already know, okay, if our TV cable is not done properly, TV has some kind of an impedance. Anybody knows what is the impedance of the cable coming in from our cable providers to our TVs? It has some resistance. It has some impedance there.
Sir, it is normally 50 ohm or 70.
So
Like
the so the so the so the cable, the copper cable which is coming in, or that we call it like a
coaxial cable.
coaxial cable, usually they have 75 ohms, which is coming from the outside there. So 75 ohms. So usually TVs also have 75 ohms too. Okay, 50 ohm is for usually um, for um, for different data transmissions as well, or from the lab and other places too. Okay, so you need to terminate them. You may heard about this termination part. So the transmitter. Transmitter could be anything. As I said, it's sending 1010. It could be an inverter. We don't know that part. We just ignore. We call it a black box. You need a clock. Clock means that something which works on time, because you do not know when to send the data. You need a clock. That's a very important aspect. And before that, there's a digital logic. You can think about it. Take the same example of WhatsApp message. You actually send, you're writing, when you're writing text message, they're actually bits which you are sending it through. You're sending, the cell phone tower and the medium does not know what you're sending. You can be sending a photo, you can be sending an audio message, you can sending a text. They have no clue. For them, it's just a data. But internally, in cell phone there's a digital block which is doing all the fun stuff. And then one of the I think one of the teachers, I think Rashid Iqbal, was there a few days back. He talked about digital logic in detail. He's a close friend of mine too, so he did he worked about the digital logic part as well. Same thing on the receiver side. You're gonna receive the data and do all the fun things on that thing. We're not gonna go into detail what the block diagram will look like because it's too much complicated. I would recommend if you are interested in this topic to watch that videos more geared toward grad students. Here, what I'm trying to show is that what kind of understanding you need to make this kind of a system, and this system is everywhere. Is one of the most you understand that आज AI hai, tomorrow there will be some other technology, third will be some other technology, and fourth there will be some other technology. When I started, CPUs are working at like 400 megahertz. Okay, when Pentium came in at 1 gigahertz, it was like a big deal for us. Whoa, we have 1 gigahertz Pentium. I'm talking about 30 years ago. Yeah, almost 30 years ago. So you see that things change. Today, nowadays, is a time for AI accelerators. Tomorrow, there will be time for quantum computers. The third, there will be time for some other kind of a technology. The technology will be there, but one thing will remain constant: that you need to move the data from one side. Once you do all the processing, once AI do the training, once I do the inferring, whatever you do at the end of the day, you need to communicate the data to something else. Otherwise, that you data is useless. Okay. So I just give an example. So my son, he's in grade 11. He will be going to grade 11. So sometime I ask him some question. He say, "That's in my mind." I said, "Doesn't matter is in your mind or no. If you cannot put it on the answer sheet, if you cannot explain to somebody else, nobody give a damn that you understand it or no." You understand my point? So at the end of the day, things needs to communicate, and that part will never go away. Communication part. So this is a very hot field. Digital will go away. There is a time. I'm not saying the digital is gone in that sense. Most of the digital will be automated very soon with AI. Much of the analog could be automated. There are many other things which can be automated, but one thing is constant, and the constant thing is that data needs to be moved. Okay, so as long as we know how to move the data and how to understand how the data is moved, that is a really good understanding for us. So if you're doing any courses or any projects, think on those projects where you working on the communication part of the circuits there, because that will be a multidisciplinary understanding, and you will learn a lot about the whole thing rather than being an expert in a very small niche part, which is very good too. But understanding the overall big thing is the main understanding. So that's what I'm trying to give a kind of a motivation at the end of this talk, that what kind of a courses you should have paid more attention, or you should pay more attention now to be really efficient in understanding these kind of a complex systems. It's a very complex system. So the first part is passive. You see, there's a termination register there. So we call it passive. They are not active resisting. This you must have a solid. If you call yourself an electronics or electrical engineer, you must have a very solid understanding of how capacitor works, how resistor works, and how inductor works. And if I ask you how inductor works, I can tell you, I can guarantee you that 90% of you may not understand how inductor works in a actual chip. They will tell, oh, there's a coil here. They can tell you all this weird thing, and we have a coil on our in our in our fans or in other places too, or we have a coil on our tube lights or other places too. They can talk about all these things, but do not understand what actually inductor means in a chip and why it is important. And 90% of the interviews I do, many people stumble on simple capacitor, how it is charged, what capacitor is doing, what is the role of a capacitor. What is the role of a resistor? Resistor is not just simple resistor there. It has its own characteristics as well. And same thing for inductors. This is a very, very, very important thing. If I tell you that if you understand one thing really good, that should be one thing. If you do these things really well, everything else comes naturally to you. But as I said, 80-90% of the students do not have a good, solid understanding of these places and the courses you should take. That's what I'm going to talk about it. That I don't know what you call it. We usually call it circuit ones and circuit two, like a basics. Like you, what is the Kirchhoff law? What is Ohm's law? What is Kirchhoff law? Voltage division method, current division method, Norton equivalent, Thevenin equivalent. Does it sound right to you? Do you understand these concepts?
Yes,
Think,
sir.
talk to
Yes,
yourself.
sir.
Talk to yourself and see what do you understand those things or no. If you know, if you do not, and I can imagine it takes me a while that I keep learning myself these things too, because things I may not have that much understanding. So not many people have a very solid understanding of this thing. If you do, that's a really big basics you have covered, and you don't need to worry too much on another part as well. And same thing like simple microelectronic circuits, um, that that how in the microelectronic circuit you may not need to know what the actual block is. You can look from a high level overview too. And signals and systems part as well. How the signals and systems, frequency transform, Fourier transforms, frequency domain to time domain. I can write down capacitor in a frequency domain. I can write down capacitor in a time domain. Same thing for resistor. Same thing for inductor. What is the difference? Why they are different? What is their responses to the system? How they should look like? These are very important understanding. Once you have, that's a really good place to start with. Second one is the channel. Okay, there's a channel in this one. As I said, there are many different channels there, but channel is that the signal which is moving from the transmitter to receiver. I put a figure. I don't know why it didn't show up, but it goes through a medium. In this case, about PCB, and it works like a transmission line. I don't know know about what the transmission line or no, but that's what I'm trying to give words here. Okay, that this works like transmission line, and these transmission lines usually affect other things too. We have a concept called crosstalk. One line can also interfere with something else, and so on and so forth. And this is a very important topic as well. And usually, the understanding of RF circuits, electromagnetics, and engineering physics. And here we usually call it engineering physics. I don't know what we call it in Pakistan. These courses there. So electromagnetics is the I have a confession to make. Electromagnetics is the course on third year I did in NAD, and I did not pay attention to that course. I thought that course has nothing to do what I'm doing. It has no meaning in, in my life. I don't know what I'm doing, why I'm doing, and they explain it really bad as well. So that's different too. So teachers can also have an effect too. But that is a course I really did not pay good attention. I got good marks, but that's a different story. Getting good marks doesn't mean you understand the course properly. But that's the thing I really regret. I should have paid much more attention than I did. So same thing for you. You may find out something you do not pay attention. You're getting good marks, but pay attention. Go into the basics of how electromagnetics works. This is a very fundamental part of engineering. Second thing is the real front end circuits we call it, which is actual transmitters and actual receiver. These receivers can be simple as an inverter, just simple inverter, and it can be a complex drivers too. Usually they are transmitter and receiver are, we can call them ADCs and DACs. I believe you understand what does ADCs mean, like analog to digital converters. DAC means digital to analog converters. Op amps, you may work on this thing, comparators, current mirror biasing. These are the basic circuits for analog circuit design, but we call it linear circuit design. And why we call them linear? Anybody has any answer? Why we call them linear? Why we do not call them something else? Okay, yes. Who can answer? Why we call them linear circuit?
Sir, because they follow superposition principle.
Not just superposition. All the linear circuit theory or the linear algebra can be applied to linear analog circuit with some assumptions. Okay, that's a very good answer. But it's not only superposition, but you can use any other linear method, which means that if you know how to multiply matrices, if you know how to solve a linear equation, you can you can
Yes, sir.
you can model your circuit as a linear circuit with the caveat. What is the caveat here? You can only model it as linear when. Anybody any answer? You can only call it linear when we bias it on a linear operation. Okay? If you learn about op amps and other places, there's a biasing concept. There's a concept of DC analysis. You bias your circuit such that we can model that analog circuit as a linear block. Okay, that's a very important concept. It's a digression, but it's very important if you take these if you take these analog courses, pay very close attention how they are actually being used. So now we're gonna go to the next topic. So now clocking comes in. Clocking is one of the most important things we talked about. That clocks are they are the heartbeat. Is if I take our body as the thing which we communicate, I'm using my mouth to communicate. That's my transmitter. Okay, and you're receiving through your ears on other senses too. So the receiver is on the other side there. But at the end of the day, we have a heartbeat which tells us to do things on a specific time or a beat. Usually in a circuit, it's called clocks. Because there's no clock, nothing comes out, no matter what's happening there. You can have an amazing mouth, but if your heart is not beating, it doesn't matter. Okay, so same concept. I usually consider clock as a heartbeat of a main circuit. So some people wants to be a surgeon on heart because they know this is a very important thing. If we fix heart, we can fix the person. And that is important as well, that if you want to take a project or a course, take a course where there's the concept of a clocking inside there. There's a clocking concept and this is called CDR, clock and data recovery. So there are different names to this one. Clocking includes phase lock loops, delay lock loops, they call it, injection locked oscillator. It's called resonant clocking, clock and data. These are all different jargons you may hear or heard about them in a different concept in different blocks there, but they are very important in our discussion, and they're usually done with a non-linear analog circuit. We call them non-linear because they are not linear circuits. They behave non-linearly. There's no linear concept you can apply. So there's a different ways to solve those circuits. Okay. Now we go to the left hand side. I think we talked about it in a few minutes ago. That at the end of the day, your cell phone, your laptop, your computer, they're all digital. They're all doing digital processing. AI processors are doing everything digital, and that digital logic includes using an RTL, using Verilog, VHDL, using a synthesis, place and route, timing, jitter, skews. They're all part of a digital communication, and you usually want to learn these kind of a digital circuit courses to be really familiarize yourself as well. The other concept is the DSP. A DSP is one of the most fundamental blocks nowadays, which is doing the digital signal processing. So at the end of the day, all the real signals are analog. Okay, all the senses, the one I'm talking, my words coming out, the sound coming out from my mouth is all analog. They will be converted into digital and send it through the channel through Canada all the way to NUST campus. They go to digital eventually, but at the end of the day, this is all analog. And at the end of and these Google Meet and other places, they're doing some kind of a processing on that analog signal, mostly done on a digital signal processing. This is one of the most critical blocks to understand different kind of a calibration adaptation. Whatever I'm seeing, if they do not code it properly, then you cannot able to see me. You're seeing my video as well. You're seeing my audio. There's no lag. All these fun things were done in a DSP. That how should we compress the data? How should we modulate the data? How should we send the data? This all fun things are done in a digital signal processing. And to understand that thing, I think you should make sure that you pay attention to this digital signal processing and digital communication theory courses. Okay, because they're gonna help you a lot in understanding um, the basics, how things can be improved for the whole channel there. At the end of the day, you need to simulate everything. You already know how to simulate everything. And then there are some EDA tools. I'm from Synopsys. There are Synopsys tools. There are other companies who have other tools as well. And you just do not just want to run only the tools. You want to understand how tool is actually behaving. If I'm sending a current to a capacitor, how the voltage is going up. You already know the math. You already know the differential equations, and you need to understand how the EDA tools are implementing those ones as well. So here the math aspect comes into play as well. You may be doing math 1, math 2, math 3, or advanced math courses as well, which include statistics, probability, differential equations. They are really useful. They come really, really handy if you really understand what is actually meant by them in a real scenario. Okay, so do not skip the math courses assuming that they are the kind of useless, or just do the how to solve a probability question there, or how to solve one statistics question. They give you a question, you learn by heart. The same question comes in the exam, you just and you get 100% marks on statistics and you are very happy. That you should not do that thing. These are the courses you really understand what is actually meant by statistics, what is actually meant by probability. If I can tell you, um, I just finished a book. I'm gonna see. Oh, here's my book. Just give me maybe it's okay. So I don't know. Anybody can see. Can you see it, or is it upside down?
Right now, your slides are visible.
No,
Let
no.
me
Can you see
see.
my camera? Can you see
Yes,
my
sir, we
camera?
can.
Yes,
Yes,
sir.
sir.
Yes.
By machines learn.
Exactly. And it's called The Elegant Math Behind AI. It's an amazing book. This telling us that all AI and machine learning is just statistics and probability, and a very little of differential equation. And I loved every single page of that thing. If you can read that book, that's amazing book. Uh, but that will tell you the power of math. If you understand these basic concepts, you are already much further ahead than your peers. Okay, so just um, just spend more time on that thing if you can do that. Uh, so at the end of the day, you need to lay them out on the circuit, on the chip design, physical. So usually you need to take these VLSI design courses, and you also have to take semiconductor physics courses too. Some of these courses are much more advanced, like semiconductor physics. This is about more chemistry, how the physics work on the semiconductor, the crystal structure, what are the equations are used, what are the valence bands, and all these fun things. It's not very easy, but if you have a very strong basics on math, on physics, this course will be very handy for you to be better than anybody else. And same thing for the VLSI design. At the end of the day, once you design the chips comes back, you need to put it on the PCB for the PCB testing, and then you need to understand how the PCB design works, how the world works in terms of communication in the labs, what are different scopes you're gonna use in the lab, and so on and so forth. And and at the end of the day, you need to communicate that. with the chip as well. And most of the communication, not most, all the communication are going through you. Somebody talked about UART. Another thing, you need to have some kind of a code or a C code or a Python code or a MATLAB code to communicate from your test structure to the chip. And that's why the programming languages comes in handy. Those people who have a better understanding of programming languages, C, Python, who are better than anybody else, they always have an advantage compared to pure analog circuit design or pure digital circuit design and so on and so forth. So you can understand that I encompasses almost all the languages in the thing. But at the end of the day, the chip has to make money. If the chip is not making money, then you're screwed. there's nothing there's nothing left. There's nobody gonna pay for you, and you're doing the course as well, that you believe that there is a business, or there's a company, or there are a group of companies, or there are biggest companies that are available who are making money making chips. You know, the first company who became $4 trillion is Nvidia, and Pakistan has, I don't know how much, $220 billion debt or something like that. I don't know that much, but how much debt Pakistan has it. But compared to one company or semiconductor company who designed a chip, that it is $3 trillion with one company, and they're saying that the top 10 companies are like $14 trillion. Think in terms of $1 trillion is how much zeros it has. Okay, so that's a business model. So you need to sell the chip at the end of the day, and then usually for those ones, you need to make sure you also take courses on business, marketing, sales, and specifically communication part, because at the end of the day, you need to communicate your design to the audience. Okay. So as I said, sometimes I do not write down economics courses there, because it's many. At least when I was there, it was engineering economics you used to read. Now I think there are many other marketing courses into this thing. At the end of the day, we are all selling, so should be a part. Negotiation should be part. You should learn these skills as well to be a better engineer. They are not the other way around. People who go to do MBAs and marketing before doing the engineering, they're always behind those who know the engineering part, they know the technical aspect, and they complement it with these kind of a courses, not the other way around. That's what I put this one at the end. If are not good with this one, that's okay, but you cannot be bad with anything else, which I stall behind that one. Okay.
Nikhil Hassan has raised
Yeah.
his hand. Mr. Naki?
So sir, like you have explained a lot of fields there. So what is the most promising field in the future, like analog or digital, or there is a main mixed field in there?
So, so that's a question you need to think yourself. What I'm trying to tell you is that these all courses, what you do, which are available in your school, when I say school, here in North America, everything is school. We call it school. Even university, you call it school. When the thing which you're learning in your universities and in your undergrad or your grad, or you're doing your own courses, you must pay solid attention to those courses further than even what they're taught in the class by the teacher. But sometimes teachers, they do not even know themselves what they taught teaching. So you should not be bothered by their understanding or whatever they're asking. You should make sure you have a solid, because these will only help your basics. They're not gonna make you expert. Okay.
Okay, sir.
So
So
once you go through all the courses, then you know I am really good in math, maybe, and I understand math better than. And how do you know? How do you know that part? That's a very important thing. So Naki, if you think somebody comes to you and say, okay, Naki, can you help me on this programming thing? Can you help me? I do not understand how to write the code of C. And you will see many people coming to you for coding. That is your thing. This is actually the universe is telling you you're good in this thing. You should focus on that thing. If you help people, people come to you for analog courses, and they say, okay, I do not understand this op amp, and you tell them, oh, do this thing, do the biasing, and people say, oh wow, you're a genius, you understand. It's not genius. You have a tendency that nobody else knows, but they recognize better than you. So you cannot focus the shiny thing. You should focus on everything, and and the environment will tell you you are good at what, and focus on that thing. That should be your future goal. Not analog, not digital, something you are really good at, and you will be good at something you pay attention to. Okay, so
Okay, sir. Okay.
Dr. Numan, I would like to bit add on this question. So I think at this early stages of the career, thinking about analog, digital, mixture, that's too early. So you can come up with this kind of question once you are ahead in career. Then when you have the basics of all of these, as Dr. Numan said that if you want to excel in the professional life, you have to know the basics of all of the domains. Then you can become a valuable team member. So if you are in the higher, grow in the higher ranks in the career, then this would be very valid question. But at this level,
yes.
try to focus on all of the domains that you are working on.
So you understand that. So me, Rashid Iqbal, and Rashid Ramzan was senior. I'm just picking three of us. We went to the same university in Linköping in Sweden. We end up with three different careers. Rashid Ramzan is a super expert in RF circuits and all these things. Rashid Iqbal, the other guy, who just I think he did on
Yes.
his talk on Monday.
Yes.
He's a digital expert. He's been with Intel for many years, and I end up with analog. I love analog more than digital, so I'm in analog circuits. We went to the same courses, we took the same courses, same universities, same concept. Our inputs are the same, but we end up in different places um, based on different expertise, and we become experts in our field too. So there's no one field you should pick and choose. As long as there's a concept, there's always a seat vacant at the top. If you are at top of your class on specific thing, you do not need to worry about other things. Do not run for shiny things. Run for something which you're really good at. You should spend all your time reading the books. There's nothing. Nobody's saying कि आपने जो किताब पढ़ ली है बस वो पढ़ ली है. You go back to the basics. I keep updating my basics again and again and again because there's so many things to learn over time. So just go back. As long as you recognize that you messed it up or you do not know exactly, you go back and try to understand it. There are many YouTube courses. You don't need to read books as well. Just pay attention that I really want to understand this course. I want to spend like there's a concept that you need to spend 1,000 hours on one topic to be an expert on that thing. So think about it. How are you gonna put 1,000 hours?
Thank you very much, Dr. Numan. We are already have passed the time with 15 minutes. So thank you very much for sparing time for this activity. And thank you for the all of the audience to join this session. So now we would like to sign off from today's session.